Sorry about that, ran out of battery. So, as I was saying, let's graph this out and see if it looks into the future. So we're going to assume that we're currently at t is equal to 10. We're going to just plot out some random function. It doesn't matter what x of t is because we're just doing this as an exercise, so I'm just going to kind of draw a squiggly line. Let's imagine that this is y of t. So this is the out, or I'm sorry, this is x of t. This is the input. We're going to build up the output. Let's say that right here is 10. And so, if t is equal to 10, in this term, we've got 10 plus 3, which is 13. And in this term, we have 10 minus 4.8, which is 5.2. And so we can trace these up, find a point on the axes and trace these over here. And let's say that this point is going to be, I don't know, 2. Time is currently 10, but 10 does not figure into this, so we don't need to trace its line over. This is the present. We trace it up, and I didn't do a good job because these lines are going to overlap, so I'm just going to kind of bring it on up this way a bit. Pretend that's a straight line, and let's just call this a value of 3 just to differentiate between these 2 points. So this is the future, and this is the past. And so when we build up y of t, which in this case is y of 10, this is going to be equal to x of 10 plus 3 plus x of 10 minus 4.8. This is going to be x of 13 plus x of 5.2. We can substitute the values in that we found. So we can say x of 13 is 3 plus x of 5.2 is 2. And so we can say y of 10 is going to be equal to 5. So we can solve this problem out. Given this equation, given all the information we know, we can solve it out. However, when we look at where we're getting the values from, 10 is the current point in time. 5.2 is fine, it's in the past. 13 is in the future. So because of this term, the t plus 3 is not causal. So the best way to determine if something is causal is to bring in some values of t, plug in some values of t, just like we did here. You know, just make up some values, plug them in. If you're like, is this in the future? Say, okay, let's assume t is some value. Assume it's 10, and then plug 10 into this. 10 plus 3 is 13, that's in the future. So, that's the third property. We're not going to worry about these that much, but what you need to make sure of is that when you put things into here, there are always time delays. When you start building up these systems, make sure they're time delays, which is a t minus t naught. Put things in the past. We can't look in the future. So, the last thing that we're going to do, I'm going to leave you with something to think on. So consider the system. Y is equal to x of minus t squared. Is this system linear? Is this system time invariant? And is this system causal? So consider this a little bit. Think about this a little bit. Y is equal to x of negative t squared. And guarantee that you're going to see this again.